The Getting Started with Scripting in ArcGIS 9 live training seminar. My name is Krista Page, and I will be your presenter for the seminar. With me today is Jeremiah Lindeman, who will be helping to answer your questions. In this seminar, we will cover 3 topics. Topic number 1 is a quick introduction to scripting. In topic 2, we will discuss what scripting functionality Python offers. In topic 3, we will discuss what scripting functionality ArcGIS offers. Topics 2 and 3 are followed by a software demonstration, a review, and a Q&A session. During the presentation, you can send Jeremiah and I questions. During the Q&A session, we will do our best to answer as many questions as possible. So let's get started with topic number 1, Introduction to Scripting. There are many reasons why people write scripts, but the number 1 reason that most people write scripts is to automate a workflow. For example, maybe you have to project and clip a series of feature classes in a geodatabase. Instead of projecting and clipping each feature class on a task-by-task basis, you can throw the whole process into a script and have the script do the tedious work for you. Another example might be that you have to update a feature class with daily GPS readings. Every day you receive new GPS readings, and every day you have to take those readings and manually add them to an existing feature class. Instead of repeating this task every day, you can write a script that will automatically update the feature class for you. With scripts, you can even set them to run at a specific date and time. Being able to run a script at a specific date and time is another reason that people write scripts. Having the flexibility to run that script in the middle of the night, when there is not much demand on the server, might be a huge benefit to some people. A third reason that people write scripts is because they are very easy to distribute. Scripts are stored in a single self-contained file. There are no extra files to worry about. The final reason that people write scripts is because they tend to be easy and quick to write. If you compare a scripting language to a programming language like Visual Basic, you will find that scripting languages generally require fewer lines of code and have much simpler syntax. Many ESRI products offer a scripting environment. For example, ArcInfo Workstation has AML, ArcView 3.x has Avenue, and now ArcGIS 9 provides a scripting environment as well. Unlike previous versions of the software, ArcGIS 9 allows the user to pick from numerous scripting languages, none of which are owned or managed by ESRI. Some of these scripting languages include Perl, VBScript, JScript, and Python. Now, since there are so many languages, ESRI had to choose one to primarily support, and we chose Python. Python is installed with ArcGIS 9, and most samples and help documentation are presented with Python code. All the code in this seminar will also use Python. Now, for anyone out there that currently uses AML, Avenue, or Visual Basic, you might be wondering what exactly can be done with ArcGIS 9 scripting. And for those of you who have never done any scripting, I'm sure you are wondering the same thing. Well, for the next 55 minutes, we are going to focus on that question. What can be done with ArcGIS 9 scripting? What functionality is available? Well, there's really 2 parts to the answer of this question. The underlying scripting language itself offers some functionality, and this functionality will vary from language to language. And then ArcGIS offers some functionality that is language independent. The following 2 topics in this seminar are divided up based on these 2 parts. First, we will look at what the scripting language offers, in our case Python, and then we will look at what ArcGIS offers. So let's go through a quick list of the functionality that we are going to cover. The first thing that Python offers is a location to write and execute code. The second thing that Python offers is a series of data types, including strings, numbers, lists, files, etc. The third thing that Python offers is a wealth of functionality tied up in modules and functions. And the fourth thing that Python offers is a series of statements. All four of these things, location to write and execute code, data types, modules and functions, and statements, are specific to Python. Other scripting languages, such as VB Script or JScript, do offer similar functionality, but in a different flavor. Now, the first thing that ArcGIS offers is a set of geoprocessing tools and environment settings that can be run or set from any supported scripting language. The second thing that ArcGIS offers is the ability to create data descriptions. The third thing that ArcGIS offers is the ability to create lists of data. ArcGIS also offers the ability to manipulate rows in a table or feature class. The fifth thing that ArcGIS offers is the ability to work with geometries. For example, create new point or line features. And the final thing that ArcGIS offers is an execution environment, an interface to run your script from. Now, all of this functionality, tools and environment settings, data descriptions, data lists, row manipulation, geometries, and location to execute code, is available for any supported scripting language. It is not just specific to Python. Well, let's take a look at what Python can do. The next 4 slides correspond to these 4 boxes. What Python offers. The first thing that Python offers is an environment where you can write and execute your code. The application is called PythonWin and is installed with ArcGIS 9. In the scripting world, PythonWin is kind of the equivalent to one-stop shopping. From PythonWin, you can write, test, debug, save, and run your code all from one location. You can write most of your code in what's called a script window. You can test individual lines of code in the interactive window. PythonWin offers a set of debugging tools built right into the application. These tools will help find your errors. You can save any of the code that you write using the Save button on the standard toolbar. And you can run your code by clicking the Running Man icon on the standard toolbar. The second thing that Python offers is data type support. Python can store and work with many types of data. The 4 most common types of built-in data types that Python supports are numbers, strings, lists, and files. Tuples and dictionaries are also common built-in types, but we don't have enough time to discuss them all. Numbers are simply numeric values. They can store integers, floating point values, complex numbers, the result of an expression. Strings are an ordered collection of characters used to store and represent text-based information. Strings can store something as simple as a path name or something a little more complex like a where clause. Lists are a collection of ordered values that are indexed, meaning you can pull individual values out of the list. The indexing starts at 0. Files store the contents of a file. In Python, you can open, read, and write to files. The third thing that Python offers is modules and functions. A module is simply a file that contains functions, and a function is simply a task that returns a value. Most of Python's functionality is locked up in dozens and dozens of modules. To access the functions in a module, you need to import the module. In the example on the slide, 3 modules are being imported: the math module, the string module, and the os.path module. Once the module is imported, you can access the functions in a module by prefixing the name of the module to the name of the function. For example, to access the square root function in the math module, type math.sqrt. This function returns a value of 8. Some modules contain dozens of functions, and other modules contain just a few. In total, there are hundreds of functions available to any Python programmer. The fourth thing that Python offers, and the last thing that we will look at for Python functionality, is statements. Statements are very similar to functions in that they perform some task, but they differ from a function because statements do not return a value to the user. Here are some examples of very common statements that you will use over and over again in your geoprocessing scripts. The first one is the import statement that we just looked at on the last slide. The import statement imports a module. The second one is the print statement. This statement is generally used to send output from a script window to the interactive window, the window that we use for testing. The third set of statements are conditional statements. Every programming or scripting language has the ability to make decisions. Python uses the if, elif, else statements for decision making. Python also supports looping and uses the while and for statements to manage loops. To handle and trap errors, use the try and except statements. If you throw all of your code into a try statement and there is an error with that code, Python will automatically skip to the except statement. In the except statement, you, as the programmer, gets to decide how to handle the error. Well, we just looked at the four main things that Python has to offer: a location to write and execute code, the support for many data types, dozens of modules and hundreds of functions, and many built-in statements. Python also offers a lot of additional functionality, like the ability to make your own classes. But we obviously don't have time to cover everything. What we are looking at is the basics. At this point, let's do a software demonstration to hammer home some of these concepts. I'd like to move over to Python Win, which is the application that allows us to write our code, debug our code, test our code, save our code. Everything can be done from this particular application, and this application is installed with ArcGIS 9. Down at the bottom, we see the interactive window. This is the location where you can test your code. We can open a brand new script window by going to File, New. And the script window is generally where you write your code. So let's save the script window. Once you write some code in your script window, you can run it by clicking this running man icon. If your script happens to produce an error, you can debug the script using the debugging tools up here on the debugger toolbar. So let's write some code. The first thing I want to take a look at are those modules and functions. And remember, to import a module, we use the import statement. So let's import the math module. The math module is one of the modules we looked at back in the presentation. Now, from the math module, we can grab the square root function. We can grab the square root of 64, which would return a value of 8. To test this, to see the output from this, we might throw the print statement in front of the math.squareroot function. The print will send output down to this interactive window. So let's click our run icon, and notice down in the interactive window a value of 8 is returned. Now, math is just one of the dozens and dozens of modules that are available for you to work with. If we take a look in Python's help, there's a global module index that will take you in and show you all of the different modules that you can work with in Python. Okay, there's lots of these different modules. Math is a module that we just took a look at. If you click on the math module link, it will take you into that module, and you can actually scroll through and see all of the different functions that are available for that particular module. If we scroll down far enough, we will find that square root function that we just worked with. A couple other modules that we took a look at in the presentation were the string module and the os.path module. Those have links as well. You can just click on the string link or the os.path link. and that will take you into their modules and show you the functions that are available for those modules. Okay, well, let's leave functions and modules for a minute and take a look at some of Python's functionality, some of its other functionality. Well, let's take a look at its conditional statements. So I'm going to use the if, else statement. I'm just going to type a little bit of code. Let's say x is equal to 6. Then I'm going to say if x is equal to 5, then I want to print down to the interactive window the value of 5. Then I'm going to say else if x is equal to 2, then what I want to print down to the interactive window is a value of 2. Else, if x is not equal to 5 or not equal to 2, let's print down to the interactive window not 5 or 2. So this is just some very simple code showing you how to use Python's conditional statements. In this particular example, we assign x a value of 6, and then we start testing the value of x. If x is equal to 5, we jump in and do this statement, and then the conditional statement is over. But if it's not equal to 5, we test to see if it's equal to 2. If it is 2, then this statement is executed. If it's not 5 or 2, then this final statement is executed. So hopefully, if you're following the logic, you'll realize if we run this script that not 5 or 2 should be printed down to the interactive window. So let's run the script. And down in the interactive window, that's exactly what we see, not 5 or 2. Okay, so again, a very simple syntax here, or a very simple example here, but want to point out the syntax. Notice at the end of each condition, we use a colon. That is something that you have to do in Python. At the end of each condition, use that colon. And the colon is what causes the indentation when you press enter. Also notice that for the conditional statement, there's no end if statement. There's no way to tell Python that this conditional statement is over. And that's because Python uses indentation. As soon as you unindent your code, Python knows that that particular condition is over. Okay, so for those of you who have worked with programming or scripting languages before, that might be something new for you to get used to. Okay, well, I want to continue on looking at Python's looping ability. So what I want to do is I want to comment out all of this code. I'm just selecting it all so that it doesn't run again. I then right-click, click Source Code, and click Comment Out Region. Okay, now that code will not execute. So let's take a look at Python's while loop. So I'm going to assign x another value of 10, and I'm going to say while x is less than 20, colon, notice when I press enter, it automatically indents for me. I'm going to print the value of x to the interactive window. I press enter again, it's still indented, and then I'm going to increment the value of x by 1, press enter again. To unindent, I can just press enter a second time. So this is Python's while loop. Again, a very simple example. We assign x a value of 10, and then we go into the while loop. While x is less than 20, as long as x is less than 20, go into this loop and perform these actions. At this point, x is less than 20. It's equal to 10. So we go into the loop, print the value of x to the interactive window, and then increment x by 1 so that it's now equal to 11. So when we run this loop, we should see the value starting at 10, print it to the interactive window, all the way up to 19. Once it hits the value of 20, it no longer goes into the loop. So let's run this code. If we come down to our interactive window and we scroll down, we see the value of 10 all the way down to the value of 19, and it stops at 19. Again, very simple example, but showing you how Python's looping works. Again, you have to use that colon, and notice there's no end while statement or end loop statement. As soon as you unindent, Python knows that that loop is over. Okay, well, let's comment out this code. Again, we'll just select it. We'll right-click, go to Source Code, and click Comment Out Region. The final thing I want to take a look at here is Python's data types. So we just looked at Python's modules and functions, and we looked at Python's conditional statements and loops. Now I want to look at those data types a little bit. I mentioned there's a number of different types of data types. Numeric would be one of them, and we see that X can store a value of 10. That is a numeric value. But a couple other ones that I want to look at is maybe the list and the string. So let's make a variable that holds a list. We'll call it FC list, and we'll set it equal to a series of feature class names. So let's say roads, streams, and we'll go with land use. And notice that lists are surrounded in brackets. Okay, that's what defines a list in Python. Now lists are indexed, and they start the indexing at 0. So for example, if I said pull value 0 out of the list, I would get roads. If I said pull value 1 out, I would get streams, and pull value 2 out, I would get land use. With list, you can also grab a range. So for example, I'm going to grab from my list value 0 to 2. And I want to print that result down to the interactive window, so I use that print statement. Now the funny thing about Python's lists is it will start at this position, the start position, and grab roads, and it goes to position number 2, but it never grabs that last position. So in this case, we'll get 0 to 1. It should return roads and streams. So let's run this code. And that's exactly what we see down in the interactive window, the values of roads and streams. Now the last data type I want to take a look at is strings. Okay, so in a variable called FC, I'm going to store a string called railroads.shp. So this would represent a particular name of a shapefile. Now strings are also indexed, and I can pull out a series of values. And what I'd like to pull out here is value 0, everything from the beginning, but I want to cut off the last 4 values. I actually want to cut off the dot, the S, the H, and the P. So now if I run this, what I should see down in the interactive window is railroads without the .shp extension. So I'm going to run this code. We'll scroll down to the bottom of our interactive window, and that's exactly what we see. The last output is railroads. Now this might be useful to you, for example, if you want to convert a series of feature classes, a series of shapefiles into feature classes in the geodatabase, but you want to drop the .shp extension, this might be a very easy way for you to do that. Just grab everything from the beginning and drop the last 4 characters. Okay, well that's all I'm going to show you in the Python Win application. Just as a review here, or just as a sum, Python has full support for data types, loops, conditional statements, and it gives you access to hundreds of functions which are stored in modules. So let's return to our presentation. And let's do a review of the topics we have covered so far. There are 4 main reasons why people write scripts: to automate a workflow, to have the flexibility of running a program at a specific date and time, to have an easy way to distribute functionality to a user, and because they are very easy and quick to write. ArcGIS 9 provides a scripting environment where users can choose to code in one of many different languages. ESRI has chosen to primarily support Python. Python offers a lot of functionality, including, but not limited to, a location to write and execute code, the support for many data types, dozens of modules and hundreds of functions, and many built-in statements. At this point, we are going to take a few minutes to answer some of your questions. I will now turn it over to you, Jeremiah.
Okay, thanks, Krista. Peter from Englewood asks, where can I download Python Win from? So first, to reiterate what Krista mentioned, is that when we install ArcGIS, Python and Python Win is included. So you don't need to worry about going out and installing anything. You automatically get this scripting environment to use when you install ArcGIS Desktop. Now, if you have the case where you don't have ArcGIS Desktop yet, and you want to start looking at Python, and you know you're going to be working with it in ArcGIS in the future, you can download Python for free. So that's one of the advantages of using Python, is that it's for free. If you want to download Python, there's actually two parts that you would need to use Python Win. You first need Python, which gives you access to the scripting language itself, which you can download that from www.python.org. And it's a free download. And that just gives you access to Python itself. And then you also need a separate download for Python Win, which was the application Krista was using to write the scripts. There's also links on python.org to download Python Win as well. Okay. A couple of you ask, how do you start Python Win? Well, once you have Python Win installed, it's just as easy from going to the Start menu, going to Programs, and you should see an option for Python Win. See, Jim from Rochester asks, does Python have a debugger? Yeah, that's one of the advantages of using the Python Win application Krista was using, is that it does have a debugger. It has its own debugging toolbar. This means that we can set up breakpoints to see where our code might be having problems, step through our code line by line to examine it more closely, see where we may have made syntax errors or how we're interacting with our data. See, another question, Cindy from Oakland asks, can I run a script at any time, and how can I do this? Well, you can do this with the Windows @ command or using the Windows Scheduler. This is by going into the control panel. And then what you'll do is you'll just point to that Python file, the py file, and you'll tell it what time you want to run it. She also asked, if I want to run a geoprocessing script outside of ArcMap, can I do that as well? Yeah, we don't even need to have ArcMap or ArcCatalog open. As a matter of fact, what Krista's been showing is just what we can do with Python itself. We haven't even got into ArcObjects yet, is what she'll be getting into next. And you can run these scripts without having ArcMap or ArcCatalog open. Okay, I'll turn it over to Krista now.
Okay, we'll take two more questions here. Robert from Austin asks, is Python 2.3 okay, or should I uninstall it and revert to Python 2.2? Well, Robert, when you install ArcGIS 9, what gets installed by default is Python 2.1. And that's fine, but you can also overwrite that and install Python 2.3 on your own. Now, there will be a few minor differences between something like Python 2.1 and 2.3. For example, in Python 2.3, Boolean values are returned as true, true, and false, false, whereas in 2.1 they're returned as a 0 and a 1. So there's a few minor differences like that, but nothing that should prevent you from using any of the valid versions of Python. I'll take one more question here. Mel from Alabama asks, what are the most common modules to import for GIS? There's probably 4 different modules that I use a lot. The OS path module is very useful. It allows you to grab the base names and the directory names for different paths. The string module, if you want to do any sort of string manipulation, which is very common, and we'll actually take a quick look at the string module and some code that's coming up. That's a very useful one. The math module, if you want to do any sort of mathematical calculations, maybe do some mathematical calculations to add new values into a new field, that might be a useful module for you. And the final module that we use a lot is the SYS, or the SYS module. And in that module, there's a number of things that you would work with. For example, there's a function in there called exit, which is very useful. It allows you to prematurely exit a script. And the other one that you will use a lot in there is the ArcGV function, which allows you to accept dynamic input from the user. Well, now I'm going to ask you a question. Before I do, locate the review question link in the upper left corner of your browser window. Here is the question. Which of the following performs a task but does not return a value? Is it A, a function, B, a statement, C, a module, or D, a script? To submit your answer, click A, B, C, or D, then click the Send button. We will answer this question later in the presentation. Our third and final topic focuses on what ArcGIS has to offer. The ArcGIS functionality is available regardless of the underlying scripting language that you decide to use. ArcGIS offers tools and environment settings, data descriptions, data lists, row manipulation, geometries, and a location to execute your code. The next 6 slides correspond to these 6 boxes. The first thing that ArcGIS offers is a set of geoprocessing tools and environment settings that you can run or set from any geoprocessing script. A tool is simply a geoprocessing operation, like a buffer, clip, projection, or data conversion. And an environment setting is simply a common setting that is applied to all tools. For example, maybe you want all of the outputs from your buffer and clip operations to go to one folder. If this is the case, you can assign that folder to the workspace environment setting. All geoprocessing tools will then honor that setting. The first thing you do when you start to write a script is you type in these 2 lines of code. The first line imports a module. This module allows you to work with ArcGIS's geoprocessing functionality. The second line of code gives you access to the geoprocessing functionality. You usually store that functionality in a variable called GP. From GP, you can access all your tools and environment settings. After you have created the GP variable, just prefix it to any tool or environment setting. In the last 3 lines of code, we are setting the workspace, buffering a feature class, and erasing features from a feature class. The third line of code uses the workspace environment setting, and the last 2 lines of code use the buffer and the erase tools. Any environment setting or tool can be called in this fashion. The second thing that ArcGIS offers is the ability to create data descriptions. You can describe feature classes, geodatabases, feature datasets, coverages, and many other types of data. Once you have described a dataset, you can use that description in your code. In the example on the slide, we are describing the zip codes feature class and storing the descriptive information in a variable called DSCFC. One of the descriptive pieces of information that you can get for a feature class is its shape type. Using Python's if statement, test to see if the zip codes feature class is a polygon feature class. If so, we will do some area calculations. Now maybe you are wondering what other descriptive pieces of information you can get for a feature class. Well, here is a list of the available properties. You can get the feature type, whether the feature class has M or Z values. You can get a list of the fields, the extent, and there's many more here as well. Each type of data you describe will have a different set of properties. Let's look at one more example. In this example, we are describing the ERELEV raster dataset. The raster dataset is represented by the blue outline. The descriptive information is stored in the DSCRD variable. One of the descriptive pieces of information that you can get for a raster dataset is the extent. We use that information as input into the clip tool. We clip the green dataset, AR Hill, to the extent of the blue dataset, ERELEV, and call the output ER Hill. If you are wondering what other descriptive pieces of information you can get for a raster dataset, let's have a look. You can get the band count, the compression type, the mean cell height, the pixel type, and there's many more available here as well. The third thing that ArcGIS offers is the ability to create lists of data. You can get a list of all the fields in a table or feature class, all the rasters in a folder, all the feature classes in a folder, and many other lists are available as well. Once you get a list of data, you can use Python's while statement to loop through each value in the list. In the example on the slide, we are listing all of the raster data sets in the Tahoe folder that begin with the letter H. We then loop through the entire list, building pyramids for each raster data set. Build Pyramids is a geoprocessing tool. The fourth thing that ArcGIS offers is row manipulation. You can read, edit, and assign attribute values to rows. You can also add and delete rows. This functionality is referred to as cursors. In the example on the slide, we want to replace all of the occurrences of the word interstate with the word INT. We want the table on the left to look like the table on the right. Here's the code to do this. Notice that we use a cursor to access the rows in the Freeways feature class that have the letters INT. We then use Python's while statement to loop through each individual row. For each row, we use Python's replace function, available from that string module, to replace all the occurrences of interstate with INT. The fifth thing that ArcGIS offers is the ability to read, create, and edit geometries, or X and Y coordinates. In the example on the slide, we want to add one new feature to this coffee shop's feature class. We need to create an X and Y point for the coffee shop location. Here's the code to do that. We use a cursor to create a new row. We then create a new point that stores the X and Y coordinates. Finally, we assign this point to the row's shape field. The sixth thing that ArcGIS offers, and the last thing that we will look at for ArcGIS functionality, is a location to execute your code. You can tie your script into a tool in Arc Toolbox and run that script as a dialog from ArcMap or ArcCatalog. You can also run a script from the command line environment, just like any other tool. And finally, you can add your script to a model and run the script from there. You can take the output from your script tool and make it input into another tool. So that was the last thing that we were going to look at for ArcGIS functionality. Before we do the software demonstration, let's see how many of you got the correct answer to the review question. For which of the following performs a task but does not return a value, the correct answer is B, a statement. And it looks like about 80% of you got that correct, so that's great. At this point, let's do a software demonstration that will focus on different scripts that can be created using the ArcGIS scripting functionality. So at this point, I'd like to move over to ArcMap. In this ArcMap session, I have a map document open called sandiego.mxd. Within this map document, I have three different feature classes open: the Oceans feature class, the Zip Codes feature class, and the Hotels feature class. Also notice that I have a toolbox called Custom Tools, a toolbox that I created, that stores 5 different scripts. The S symbol represents a script symbol. Behind each one of these tools is a Python script. And we've taken that Python script and we've attached it to a tool in our toolbox. As soon as you do that, it becomes part of what's called the geoprocessing framework. And you can now run this script from many different locations. For example, I can double-click on a script and it opens up a dialog, and I can run the script from this location. It puts a nice front-end user interface on this particular script. Something else that I can actually do is I can open what's called the command line window. And in the command line window, I can type in the name of that script. Notice when I type in convert, that particular script pops up. Okay, so again, as soon as you add it to a tool in our toolbox, it behaves like any other tool, and I can run it from this particular environment. Also notice that the usage pops up as well, telling me exactly what I need to input. The other place that you can run this script from is a model. So if I add a new model or an empty model to my Custom Tools toolbox, I can take any one of these scripts and drag them into the model and run them from a model. I could take the output from this convert XY to point script, and I could attach this output to maybe another geoprocessing tool and run these tools in succession. So what I'd like to do at this point is go through these different scripts and show you how some of the functionality was created or how some of the scripts were written. The first script I want to look at is this delete file script. If I double click on this script, there's a description over here that tells me that this script deletes a set of files from a folder. Okay, notice I have a default folder in here called D, Demo Data Junk Folder. Also notice there's a drop-down list saying what kind of files do you want to delete. Okay, notice that MXD is one of those types. So let's go over to our catalog and see what we have in that junk folder. Okay, so in the junk folder, I have a series of map documents, and I want to delete those map documents. But I don't want to have to open our catalog to do that. I just want to be able to run this script from ArcMap and clean up data when necessary. So let's go back over to that delete file script, double click on it, specify that we want to delete MXD files, and click OK. When the script has finished running, hit close on the progress dialog, go back over to Arc Catalog, right-click on the junk folder and do a refresh, and notice that all those map documents are gone. Pretty simple script, but it performs some very useful functionality. So let's right-click on this script tool. You can right-click on any script tool and you can click Edit. And what it actually does is it pops up that script tool inside of PythonWin, and you can see everything behind that tool was just some Python code. Now the majority of this is just comments, and if we look at the actual code that performed that, here it is right here. Not a lot of code, you know, maybe 6 or 7 lines of code to perform something fairly useful. Notice in here we're not really using any ArcGIS functionality, we're using straight Python functionality. So we import 2 different modules, SYS and OS. We use the SYS to grab dynamic input from the user using that ARGV function. Also notice from the OS module that we're using some of its functions. We're listing the directories in a particular folder, and then we're also removing them or deleting them. Well, let's take a look at our next script called shapefile information. Now what this script does is it reports the name, shape type, and number of fields for each shapefile in a folder. Okay, so a fairly simple script. It's just going to report some shapefile information right to a progress dialog. So I'm going to click OK. I've got a folder selected. Notice I can put default values in here. I can also browse to my own location. But I'm going to click OK, and in this progress dialog, it's going to go through and it's going to list the information for all the shapefiles that it found in that folder. Notice that it found a shapefile called cities. It's reporting that it's a point shapefile and that it has 8 fields. Okay, then it reports the next shapefile and so on and so forth until it's reported every shapefile in that folder. Okay, and again, this is just being sent to the progress dialog, but we could also send this to a text file or some other location. Well, let's take a quick look at that script. Again, if we right-click and we go to Edit, this script opens in PythonWin. You can just see that there's some Python code in here. And what the shapefile information script makes use of is those data descriptions that we talked about in the presentation. Notice that we call a describe on a particular shapefile, and then we can get some fields information. We can describe the fields. Somewhere we must also be describing the shape type because we get that back as well, the point line or polygon. And again, just making use of those describe objects. Okay, well, the next script that I want to take a look at is called report geodatabase contents. Now, what this script does is it reports the names of all the feature datasets, feature classes, tables, and rasters in a geodatabase to a text file. Okay, so that might be kind of handy. It's something that's been handy for me, is I pick a particular geodatabase and I report the contents of it to a text file. So let's run this script. Okay, and it'll take a second to run. When it's finished executing, I can click the close button and we can go into Arc Catalog and take a look at that text file. Okay, I'll just refresh my junk folder, and notice a new file called GDB report has been added, and it gives us some information on what's stored inside of that geodatabase. There's one feature data set called census. Within there, there's a series of feature classes. Notice there's also some standalone feature classes, and there's a table as well. Okay, so a fairly handy tool if you're looking for a quick report on what's in your geodatabase. Let's go back to ArcMap, and we'll right-click on that tool, and we'll click Edit and take a quick look at it in Python Win. Now, what this makes use of, what this particular script makes use of, is those data lists. Remember, we can list a lot of different types of data. The first thing we list is the feature data sets. And then within each feature data set, we make a list of the feature classes. We then scroll down and we make a list of standalone feature classes. We make a list of tables and a list of rasters. Okay, and all of this is being written every single time out to a particular text file. Okay, so again, making use of those data lists. Okay, well, let's look at our next script, point count. Now, what this particular script does is it calculates the number of points in a polygon and stores a count in a field in the polygon feature class. This tool assumes the field already exists. Let me explain to you what this does. Here we have a polygon feature class called zip codes, okay? And we also have a point feature class called hotels. So we want to figure out how many hotels are within each zip code and store that in a field in the zip codes feature class. If I open the zip codes feature class, this tool does assume that there's already a field that we can use to store this information. We currently have a field called hotel count that we can use. If you didn't have a field, you could just add it. And there's also a geoprocessing tool called add field that would allow you to do this right inside of a script. But let's go ahead and run that particular script tool. The polygon feature class is zip codes, the point feature class is hotels, and the field that stores the count is called hotel count. Okay, notice how these are all available directly from drop-down lists. Click OK. It's going to run through and count each of those hotels in each zip code and store that information in the field. If we open the zip codes feature class, we scroll over to the end here and let's do a sort descending. We'll see that zip code number 92101 has the largest number of hotels, 18. And that makes sense. If you've ever been to the city of San Diego, which is in Southern California, you'll know that this is the downtown core area of San Diego. If we right-click on that script tool and go to Edit, open that in Python, what this script makes use of is row manipulation. Okay, using those particular cursors. We go through and we add the new value to each one of those rows in that field. The last script that I want to look at is called Convert X and Y to Point. Now, what this script does is it converts a text file with X and Y coordinates to a point feature class. So maybe you have some text files storing some GPS readings and you want to convert those to a feature class and you want this to be automated. This particular tool can do that. So we're going to use the attractions text file. It has some GPS readings in there, and we're going to convert it to a feature class called attractions in the San Diego geodatabase. So let's run this tool. Now we can add that attractions feature class. Here it is right here. It was just created for us. And we'll give it a little bit of symbolization so you guys can see it. And now all of these new point features have been added to the attractions feature class based on GPS readings in a text file. Okay, these include things like maybe museums and parks in the city of San Diego. Well, let's take a quick look at the code behind this script. Now, what this script is kind of showing off is the ability to work with geometry. Okay, if we scroll down through the script, you'll see that we have to make a new point feature. And then in that point feature, we assign different X and Y values. Okay, okay, creating brand new points to store in that attractions feature class. Now, the last thing that I want to mention is maybe you're wondering, how can I look at some existing scripts? And a great way to do that is to look at some of the scripts that are actually shipped with the software. So, for example, in the Conversion Tools toolbox, there's a number of tools that are actually built on scripts. Okay, any of these ones with the little S icon. So you can right-click on any of these and click Edit, and that code will actually open in Python Win, and you can view it and see how ESRI creates their scripts, and maybe borrow some of that code to write one of your own scripts, etc. And there's a number of different tools that come with the software that are actually stored as Python scripts. Okay, well, at this point, let's do a review of the last topic that we just covered. ArcGIS offers a lot of scripting functionality: tools and environment settings, data descriptions, data lists, row manipulation, geometries, and the location to execute your code. ArcGIS also offers a lot of additional functionality. For example, error checking, error handling, and messaging. We just don't have time to cover it all. At this point, we're going to take a few minutes to answer some of your questions. So back to you, Jeremiah.
Okay, thanks, Krista. Getting quite a few of you asking, does the number of ArcGIS functionalities available to me depend on whether I have ArcView, ArcEditor, or ArcInfo? And yes, it does depend on which license level you have. The second part of this lecture, Krista has largely talked about what we can do from ArcGIS within Python. One of the major things that we're going to be doing is running geoprocessing tools, or tools that are inside ArcToolbox. Now, those tools that you get inside ArcToolbox depend on whether you have ArcView, ArcEditor, or ArcInfo. If you have the full ArcInfo seat and all extensions, you get nearly 500 tools. But you get quite a few tools even with the ArcView seat. You get about 100 tools. So it just depends on which seat you have, and you need to be aware of which tools you have available to you, whether or not you can use them within a Python script. See, Elizabeth from Milton asks, is it possible to first create a model, then export it to a script? Yes, you can do that. So if you're familiar with using the geoprocessing framework, we can also create models and chain together tools, execute one tool after another. We can take our models and then we can export them to either a Python, JScript, or VB script. So this is a great to establish a workflow, a general workflow, what tools we want to execute, and then we can put in our logic into our script, set up the branching or the looping after we have the general flow in place. See, Michael from Salem asks, what is the best way to get help and find parameters for the geoprocessing tools? Well, probably the best way to find out what parameters and what syntax you need for a specific tool, for instance, if I want to run the clip tool in Python, would be to go into ArcToolbox, right-click on the tool, and choose Help. You're going to get a lot of information about how to use a tool, what the tool's intended purpose was. And at the very bottom of the page, each tool within ArcToolbox will have a script example. All these examples are within Python. So that will tell you what parameters are needed, and you can see the general syntax for how to get that tool to be used within Python. Just in a moment, Chris is going to get back to a little bit more about other resources where we can find out more information for more help for running our geoprocessing scripts. See, Oliver from Cambridge asks, can I describe shapefiles? Yes, we can. So Krista had a couple of slides in there where she was describing raster data sets. And in the demo, she ran a method that was called list feature classes. Now, a shapefile is just another type of feature class. So you can also describe shapefiles and get information about them. What is the type? Is it a point, line, or polygon? What is extents? If you want more information about what type of objects you can describe, again, go into the ArcGIS desktop help. It gives you information on all of the information for geoprocessing and what you can do. And there's also a PDF called the geoprocessor.pdf. This will give you information on everything that you can do within scripting. It has it all nice diagrammed out so you can see the workflow, what one object will lead to another. Quite a few users are asking about auto completion And does Python supply auto-completion? So when I type in a variable and hit a dot, can I see what methods or what tools I can use? Now Python Win does not support a true auto-completion when using the geoprocessing tools. The reason why this is because the geoprocessing environment is dynamic, meaning that if you're going to be using the geoprocessor to run tools, you can have a wide variety of tools inside of Arc Toolbox, depending on which license you have, and you might also put custom tools inside Arc Toolbox. For instance, you can run a model from a script. So right up front, Python doesn't know which tools you have inside Arc Toolbox, so it's not aware of which tools it should be able to run. However, you will see some completion. For instance, if I run the add field tool within Python, and then I want to use it again later on, it will recognize I use it within the script, so then I will see some auto-completion. Okay. And then another question some people are getting is, why would you use Python versus using ArcObjects and VBA? Well, you can stick with ArcObjects and VBA. It can be used to do just about anything that you want within ArcMap and ArcCatalog. Python offers a much simpler environment. You don't have to get into ArcObjects as much. You don't have to write as much code. So in general, you can write less code to accomplish some general workflows. Now, using geoprocessing functionality within Python, you can think of it as basically doing everything that you can do within Arc Toolbox. So if you have general workflows you want to establish with tools from Arc Toolbox, you can use Python to quickly put together a script that will accomplish those workflows. Now within ArcObjects and VBA, that's where you get a little bit more robust environment. If you want to create a tool where you can interact with the display and select things and interactively work with the ArcMap environment, then you probably still want to work with VBA and ArcObjects. But Python offers you a much more flexible environment to quickly get a script up and running. Okay, turn it back over to Krista.
Okay, we have time for maybe just a couple more here. Question coming in from Lancaster. If you want to share scripts with other users, do you distribute the entire MXD, MXT, or just the scripts? Well, this is how it works. You can just send the script to someone. You can send them the PY file, and they can open that in Python Win and run it directly from Python Win. Or the other option you can do is, you probably noticed in my demonstration, I had a series of those scripts attached to tools inside of a toolbox. So what you could actually do is distribute the toolbox, which is a TBX file. In that case, those scripts are already attached to the toolbox. Now, if you do that, you have to send the PY files as well. Another question coming in from Terrell and Lawrence, and I'm going to answer this one because I think a lot of people are having this problem. We converted some models to Python scripts. They ran successfully one time, then on repeated trials we had errors. What might be missing? Well, a lot of people who start off with Python, they'll run a script the first time and it works great. And then they go to run it the second time and it gives them errors. And I guarantee that the problem is probably that you have ran it the first time and that output data already exists. And now you're trying to run it the second time and Python gives you an error because the data was created in the first run of the script. So what you can actually do, there's a property called overwrite output. And you can say gp.overwrite output is equal to 1. You can throw that at the top of your script, and that should solve your problem. Okay, well, I think we're out of time, so let's just finish off here. Hopefully after this session, you have a better understanding of what can be done with scripting at ArcGIS 9. To learn more about how to script, you can take the 2-day instructor-led class called Introduction to Geoprocessing Scripts Using Python. To learn more about geoprocessing general, you can take the virtual campus course Geoprocessing with ArcGIS 9. There's also a lot of documentation to help you get started with ArcGIS 9 scripting. See the Writing Geoprocessing Scripts PDF in the ESRI library folder, visit ESRI support page, or visit Python's webpage. From Python's webpage, you can download the software, enter discussion forums, and go through some tutorials. See the 3 links on the bottom left-hand corner to learn more about some of these resources. On behalf of myself, Jeremiah, and the Virtual Campus team, we would like to thank you for participating in this seminar.